So basically, this is about trends. And I've got with me, again, another excellent panel. Michael Ford from Aegis, and then Karthik from Indium. So welcome to the stage and welcome to the show. So, trends. We can take this in all sorts of directions. Really, what I want to get a feel for, what you perceive as the key trends that you're seeing globally, wherever you're seeing them, and let's see, what those key trends are, and if they match up with what maybe the audience thinks as well. So if I can start with you, Michael.
Yeah, one of the interesting trends, of course, is how often we come across electronics manufacturing. In the past, we had specific electronic devices, like in cars, there'd be like one or two little systems somewhere. These days, a car has 30, 40, 50 controllers in it, software working all the time, everything communicating. There's hardly any appliance or any device that we have these days which doesn't have electronics. Now, you can take that on the flip side as well, because every electronic device also has mechanical components. And so we're seeing here convergence of design technologies, manufacturing technologies, where to create an overall product, it needs to go through an awful lot of steps that previously had been separate, but now need to be connected. And so we're seeing this need for connection of these different operations, and with that goes the traceability and the control and the quality, etc., all the way end to end.
But those are basically manufacturing processes that any manufacturer has been trying to achieve from day one, really, of manufacturing. You want traceability, you want to know what's going on, you want all of those processes to be connected. What therefore really is different? Is it the technology, how we're using the technology to trace the process that's changing, or is it the way we're manufacturing that's changing?
The way we're manufacturing is definitely changing. If we look at the trend for small batch production, a very high mix, things are almost being made on a bespoke basis, but with a productivity that has to match volume production. So the way of using data which is captured from each process, it includes the traceability to find out the one-off defect, the reasons for one-off defects, being able to put in practices to prevent defects from happening, so zero defect. Even the way in which, for example, we use an inspection machine. In the past, we would have inspection as an island of automation where it would be used to capture defects to make sure that no defect got into the market. Well, that's a negative sale, actually, to have a machine to find something that shouldn't have happened in the first place. Now, an inspection machine is a defect preventer, using the data in a line to find out what is going wrong with Six Sigma technology and prevent defects from happening. So it's the use of the data across these different kinds of processes that is really changing now.
There's certain industries, I suppose, Karthik, where these type of processes need to be investigated and looked at. Do you have any thoughts or examples of particular industries where the next trends in manufacturing are becoming more important?
Sure. I'd say in Europe, given that automotive is all prevalent, we'll talk in the prism of automotive electronics. So adding to what Michael said, the estimate is that the dollar amount of electronics in the car is expected to jump from $2,000 to $6,000 per car by 2021, which is not that far away. Also, Michael talked about, connectivity or system integration. And if you look at the trends or the drivers in the automotive industry, it's a fascinating space to be in. You've got more electrification in your existing car, 12 volt to 48 volt systems. You've got advanced driver assist systems, which are becoming mandatory from a vehicle safety standpoint. You've got V2X, which is vehicle to vehicle connectivity, vehicle to infrastructure connectivity, vehicle to person connectivity, and a lot of these we're seeing today. Bluetooth, Wi-Fi, mobile infrastructure, the car becoming a hotspot, making sure that accidents are limited, and then the drive towards autonomy. So we don't need to think of it as nobody being in the car or no driver being in the car, but just the different levels of autonomy which are happening today. So all of this are posing, new requirements, which then trigger down into new material sets and new manufacturing methods, and therefore new opportunities.
So we're really in, we're in a new era, I suppose, as how to think of what we're manufacturing. You mentioned the physical aspects of electrics within a car, but you're also talking about connectivity, which is this something that you can't touch, you can't feel, but it's becoming part of our overall manufacturing experience. How, therefore, are we as an industry having to adapt our way of thinking, our processes, our way of setting up our businesses to be able to cope with that next step of evolution in automotive manufacturing, for example?
Well, if you look at the news, electric vehicles, plug-in hybrids, the chargers, the charging systems, standardization, it's all, from the top down to all aspects of the supply chain is what's hogging a lot of the news, but more importantly, a lot of the R&D and work being done to be prepared for these challenges. 12 volts versus 48 volts for an existing petrol car is by itself a big deal. But now when you're talking about hybrids and electric vehicles, you're talking about 600 volts. So that's a game changer. And, it's not just a battery technology, but the inverter technology, your double-sided cool module technology. So your power modules and consequently your PCB assembly, which then drills down to the material sets, your advanced or your enhanced electrical reliability requirements. All of these are, it's completely different from what's happening today. So the status quo is no longer status quo. It's that much of a difference.
And it's changing every day really, really fast. Now, as a manufacturing software or manufacturing execution software provider, you've got that sort of overview, haven't you, of the process. So from your view, when we look at the current manufacturing landscape, what are those key changes that are taking place?
Automotive is an exciting place to be. It's great to hear all of this kind of stuff. And when I jump into my car to go home tonight, I'm going to be thinking about all of these systems working. Then I'm going to kind of remember, okay, what happens in manufacturing to create these devices? And it seems that we're putting an awful lot of trust now in electronics. We want our cars to drive themselves. These safety features, we come to depend on them. ABS braking, we leave braking a little bit later than we used to. These are kind of life and death systems. But that's always been the case in automotive. But one of the trends, the unfortunate trends that we've been seeing in the industry is the influx of counterfeit material. If you're having things like resistors or condensers even, but integrated circuits, if they are coming in and they're not genuine components, you could be building something and you suddenly detect that a component doesn't do what it should do. That's a great scenario because you can find it and eliminate it. There's lots of X-ray devices to do that, lots of ways of finding counterfeit. But what about the ones that make it through? Some of the stories that we've heard in the IPC Traceability Committee, for example, you would not believe the lengths that people go to get a slightly cheaper part into the supply chain and make a few more fractions of a cent. It is literally unbelievable. But the consequence of that can be absolutely life and death. So I think one of the trends we need to see, and maybe automotive can start this, is a secure supply chain. Something, for example, where in traceability we can relate components to material packages. Those material packages need to be now delivered securely from the original manufacturer. And it's only then when we can assure that secure delivery using, for example, blockchain to identify these materials uniquely, that we will actually be able to sit down comfortably in our car and think, wow, this trend's gone really nicely. I'm really enjoying my driving experience.
I love the way you just casually put blockchain in there. Because when you open up any magazine, blockchain is currently, I feel, one of those key trends, certainly that we read about, along with the autonomous vehicle. So let's touch upon blockchain. Do people know exactly what it is and how we can actually use the blockchain, can I call it a principle, to improve the way we as an industry manufacture?
Yeah, what blockchain actually is a kind of rule whereby you can create a code which is a secure code. What it will do is to store pieces of information that belong to that code amongst many different servers around the world. So that, with all the will in the world, somebody could come along and change data on a server somewhere, but actually the code would reconstruct itself and would detect that there's an issue and prevent the data from being changed. Now, if you think about traceability data, you may think, well, I did this manufacturing and we had this kind of problem. Oh, that wasn't actually that problem. I want to change it to be somewhere, or I want to hide it for some reason. Using normal traceability, you could go back and change a record. If it's on paper, you can just throw it away and make a new record. You can change the past. But with some things, we want to store the data very securely such that it cannot be changed. Maybe you could add to it to give an explanation or reason, but you don't want to change it. So the use of blockchain prevents people from going in and arbitrarily just changing a data point to suit their own needs, whatever that may be. So therefore, we can trust that data. And it's the trust that's the important thing. When we receive materials, when we're doing a process, when we're measuring things, we need to trust that that data is real and accurate and has not been manipulated.
So once again, there's a lot of emphasis here on data. And we've been talking about it in terms of Industry 4.0, principles, the standards that are coming up. So just to wrap it up, where do you think we're taking this whole concept within our manufacturing processes? Karthik, if I can.
Well, trust and data integrity are really important.
Yeah.
And that's where, if you look at the software companies like Apple and Google, again, in the prism of automotive electronics, you've got some trends, which is big data analysis and the integrity. So who is going to own the data and who's going to use them and what's the potential for misuse? And that's where, the user experience, who's going to own the user experience by way of securely storing the data and making sure that there are no breaches. That's key. And you're going to see that battle being fought out for the next few years.
Yeah.
And we also see the convergence of software and hardware there. So that will obviously trickle down into the manufacturing techniques, both digital as well as real.
Mm-hmm. Last words?
For data, there is always a light side and a dark side. It's like Star Wars, isn't it? Because on the light side, you can create an awful lot of value from the understanding of what's going on digitally, so that you don't need a brain the size of a planet to figure out all of the many different variables that have happened to create something which would have been a defect, which now you've sorted out. So that's the light side of data. But we also see the dark side of data, where we see people being manipulated based on understanding of personal pieces of information. This kind of processing is something that we need to be aware of and really start to control, such that when data is created and stored, that it is used for its intended purpose. But quite often, even when you go to the dark side, that data isn't processed in a way that makes sense. I mean, for example, if you go to an online shopping thing and you start to look for a particular product that you'd like to buy, you buy it, and the next few weeks, you're still getting ads to buy the same product. It doesn't know that you bought it already. So this is where a fundamental little tiny flaw goes into the processing of data, where people think that they're acting in a way that's good, but actually has no value whatsoever. So we've got to take care about the detail of the data before we start to use it.
And that's all about analyzing the data and communicating and getting those touch points right, just like in a conversation.
Yeah, it's true. I mean, we know about garbage in, garbage out in computers, and you take data from machines and stuff it into the cloud. It's just like putting data into a landfill. You know, you're not quite sure what it's going to be. It probably is going to be used, but in the wrong way. Qualification of data, knowing exactly what it is, the standardization of content, so that people know the true and exact meaning. When you've got that, then put it into the cloud and use it for all the purposes you want.
Michael, Karthik, we've run out of time. It's a broad topic, so I hope we've touched on those key trends that we're seeing.